Okay, this is going on page 79. So this is the same kind of work as yesterday, but we have to draw the pictures. So if you can't get the pictures drawn and the angles in the right place, then it doesn't matter how good you are at the other stuff. So we're not going to work every single one of these that we do. We're going to work a few of them completely, but then we're going to talk about pictures and stuff here. So let's look at number 1. It says a fire started at a campsite located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? People that have the most problems with these kind of questions are, first of all, go into it with, oh my God, I hate word problems. So if you already have that attitude, yeah, good luck. You probably have no hope. But the other thing is, yes, it's going to be a right triangle, but you don't start by drawing a right triangle and trying to label things. Because then when I come around and go, well, where's the fire? Where's this? You're like, I don't know. Well, that's because you just drew a triangle and tried to put stuff on it. Now, do you have to make it look all cutesy? No. But you at least need to know where things are in your picture. So if we have a fire, so a fire started. So here's my fire. Okay? So there's the fire. It is located 8 miles from the base of a mountain. So here's my mountain. Okay? Whatever the mountain looks like. It doesn't have to be a fancy mountain. It's 8 miles from the base of the mountain. So there's my 8 miles. And from the fire to the angle of elevation from the fire to the top of the mountain is 14 degrees. Angle of elevation in depression always has to have one side of the angle that's a horizontal line. So that would be my ground. Angle of elevation here is 14 degrees. And then how high is the mountain? So this is my X right there. And there you go. Okay? So it is a big 14 degrees. They don't have to be to scale. They just got to be something you can label and use. All right, so then to set this one up, which trig ratio am I going to use? Tangent. So I'm going to have the tangent of 14 equals X over 8. So 8 times the tangent of 14 equals X. Then we can say that the mountain is however many feet, or not feet, but 1.995 miles high. Do y'all agree with that? Height. Okay, easy enough? If you can get it labeled right, you can do the work, because the work is the same work as we've done before. All right, so then read number 3 and draw a picture. Do y'all agree with my picture? Ladder problems, sometimes I'll do weird things. The ladder is leaning, so that's your hypotenuse. How high up the wall, and then angle at the base. So this would be which trig ratio? Sine. This is going to be the sine of theta equals 18 over 32. So theta equals the sine inverse of 18 over 32. So then everybody okay with that? Good? All right. So we're going to do number 4 for a couple reasons. One reason is because it has my name in it. My name's never in word problems. So if you have a common name, your name's usually in word problems. But all right, so it says, Lana's kite is flying 60 feet above the ground. The angle of elevation from where her hand is holding the string to the top of the kite is 48.3 degrees. If her hand is 5 feet from the ground, find the length of the string. All right, so here's me. And flying a kite. So here's my kite. And so it says flying a kite 60 feet above the ground. So here's the ground. This is 60 feet above the ground. The angle of elevation from where her hand is holding the string to the top of the kite. So this is where my hand is holding the string to the top of the kite here. This is 48.3 degrees. And it says hand is 5 feet above the ground. Find the length of the string. So the length of the string would be X. Okay. All those pieces make sense? But you see I drew it in pieces also to get all the things in the right place. All right, so then which trig ratio are we going to use? Sine. So I'm going to take the sine of 48.3 degrees, and that's equal to what? 55 over x. Why is it 55 and not 60? Because you got to subtract, okay? Because this is 60 feet off the ground. This is the same 5 feet as this is right here. The flip side of that is, if I told you how long the string was and I wanted to know how high off the ground it was, then once you found this piece here, you would have to add 5 to it. So make sure you are reading the questions and that you are using all of those pieces. We don't need to finish that one up. Let's look at number 6. And we're going to use the box that number 5 is in to draw the picture for 6, so we're just going to mark that up. So it says, Sarah is standing 35 feet from the base of a rock wall watching her 2 sons, Max and John, climb the wall. The angle of elevation is 38 degrees to Max and 27 degrees to John. How many feet above John is Max? Okay, so here's Sarah. All right. Here is the rock wall they're climbing on. Who's higher up, John or Max? Max. Because first of all, John's, the angle to Max is bigger, plus it says how many feet above John is Max. So Max is up here somewhere, and John is right here somewhere. We don't know how far apart, but we got something we can label, right? So she's 35 feet from the base of the wall. There's 35 feet. And it says the angle of elevation. It doesn't say the angle of elevation from her eyes. It just says the angle of elevation, not from her hand, not from anything. So when it just states the angle of elevation, then it's going from the ground. That's just kind of that's the way it is. So the angle of elevation to 38 degrees to Max, and then 27 degrees to John. So this is 27 degrees. This whole thing here is 38 degrees. And I want to know this distance right here. Okay, so can I find that piece? Yeah. Can I use this little skinny triangle right here? No, because we can only use trig on right triangles right now. We'll get to the other stuff, but that's all we know. Even though we can figure out this angle right here, that's all we would know anyway, so we wouldn't know anything else. So can I find the 2 triangles, though? Yes. So I can find them. I can find this piece right here from J to the ground we'll call X, and we'll call this whole thing Y. That means in the end, our final answer is going to be y minus x. And stating things like that for yourself at the beginning is good, because if you're storing stuff, then once you find them, all you got to do is just subtract. But we're not even going to store here. We're going to do something a little bit different. So let's find x first. That means I'm going to use tangent. So the tangent of 27 is equal to x over 35. That means that 35 times the tangent of 27 equals x. I'm not even going to touch my calculator. Then I'm going to do 38. So the tangent of 38 is equal to y over 35. So 35 times the tangent of 38 equals y. So those didn't come out too bad as far as, what they look like. So then in the end, when I want to find z, which is the actual length I want, right, that's just going to be equal to literally y minus x. So that's 35 times the tangent of 38 minus 35 times the tangent of 27. And you can type it all in at once. And as long as you do the parentheses like you should, like you don't have to put any in, but it'll open some that you have to close in order for this to work out for you. And then we can say And I got 9. Oh, sorry. You also could have stored things in X and stored it in Y and then just done Y minus X on your calculator, but it just wasn't really necessary to do all that. Okay. What questions do we have? Anything? So, do you need a pencil, honey? I've got a ton of pencils back there. You can have them. I just realized. She's going for a world record. And you can keep it. You can have it. I got tons of pencils. All right, flip it over. Let's look at number 7. It says building A is 464 feet tall and building B is 321 feet tall. Dale is standing between the two buildings. The angle of elevation from the point on the ground is very clear here, where Dale is standing is 75 degrees to the top of building A, 48 degrees to the top of building B. How far apart are the buildings? Okay, so I got 2 buildings. Building A, here's building A, and building B is shorter, so here's building B. Dale is standing in between them, so then there's like a ground down here. So Dale's standing in between them. Okay. Oh, and this is 464, and this is 321. Dale is standing between the buildings. The angle of elevation from the point on the ground where Dale is standing is 75 feet to the top of building A, 75 degrees, and 48 degrees to the top of building B. How far apart are the buildings? Well, can I find these 2 pieces? And then the whole thing could be Z, right? So in the end here, then we're just looking for Z equals X plus Y. And we find the 2 pieces. So I'm using tangent again. So I'm going to have the tangent of 75 equals 464 over X. So X equals 464 over the tangent of 75. Then I do the tangent of 48. That's equal to 321 over Y. So Y is equal to 321 over the tangent of 48. Then Z is just you adding them together. So 464 over the tangent of 75 plus 321 over the tangent of 48. If you type that in the calculator just like it is, use the fraction key so that you do not have to do a whole bunch of unnecessary parentheses. Doing it all in one step, that's you working smarter, not harder. Because yes, again, you can store things, and there's nothing wrong with that. But sometimes you thought you stored something, and then you didn't, and you were really using a different number, and it just leads to all kinds of crazy things. So, or maybe you're using a calculator that doesn't store things, and then you can just do it all in one, and maybe you have to use extra parentheses or whatever. But, okay, what questions do we have? We good? Awesome. All right, so that's the last one we're going to work completely. We're just going to look at the pictures for some of the other ones. So let's look at number 8. It says from the top of a lighthouse 150 feet above sea level, the angle of depression to a boat at sea is 28 degrees. What is the horizontal distance from the boat to the base of the lighthouse? Okay, so here's a lighthouse. All right, here's the sea. Here's a boat. Okay. So, and the lighthouse is 150 feet above sea level. Okay, so this angle of depression, remember your angle of depression and your angle of elevation have to be measured from a horizontal. So when you draw this in to get your triangle, here's where the angle does not go. The angle of depression does not go right here because neither one of these 2 sides of the angle is horizontal. In order to have an angle of depression, you have to look straight ahead, then you look down. This is 28 degrees. So then I could find this angle, but don't do that because sometimes you're going to subtract wrong and you don't want to do that. But if this is 28 degrees, this right here is also 28 degrees because they are what type of angle pair? What type of angle pair are they? Got to pull up for somebody. Opposite's not the right word, but you're on the right track. Got parallel lines. Cut by transversal. These two angles are? They are congruent, yes, but that's not the type of angle pair. So that is correct. Well, the transversal is the line. Are they both on the inside or both on the outside? If these are my parallel lines and this is my transversal, they're both on the interior. So what kind of interior angles? Oh my gosh. I was just talking to myself 2 years ago. You're on the right track. The opposite's not the right word though. It's another word for that. No, reciprocal is not another word for opposite. No. No inverse either. What? Yeah, so what is it? So you said. There you go. Good job. Yes. Here's not the first thing you said. Okay. So they are alternate interior angles. That's why they are congruent, because you got parallel lines cut by a transversal. Good golly. All right. So then it says, what is the horizontal distance? So that's important. Horizontal distance from the boat to the base of the lighthouse. So I'm looking for this. If it just said, what is the distance from the boat to the lighthouse? This is the distance from the boat to the lighthouse, right? Well, maybe not. I mean, it depends, but it's got to tell you horizontal, or like if there was a person up here, the distance from, Tommy to the boat, that would be this. But for the horizontal distance, so look for those words so you make sure you know which pieces you're looking for, okay? Yeah, we need to, don't we? Not today. I don't know if I have the patience for it today. All right, let's look at number 10. All right, number 10, I want you to draw a picture. Read this and draw a picture. Do you agree with my picture? My deer looks more like a bowl, but it's okay. And you don't have to be fancy. You can put D for deer, just so that you know where things are. It doesn't have to be a cute little picture. And then we could go from there, right? Just want to make sure we got our angles in the right place. We good? Yes? Okay. All right, so let's look at number 12. You don't have to solve it. We're just drawing. I think y'all can solve it. Once you get them set up, y'all can solve them. I mean, because if you can do yesterday's stuff, that's all this is. You just have to set up the picture. So, we're good. All right. I don't have the answer written down. All right. So a scuba diver spots a shipwreck at an angle of depression of 26 degrees. The angle of elevation from the scuba diver up to his boat is 53 degrees. If the shipwreck is located directly below the boat and the horizontal distance between the scuba diver and the shipwreck is 120 feet, find the vertical distance between the shipwreck and the boat. That is a lot of information, right? But we know we have a boat, a shipwreck, and a scuba diver. So we can at least get some of this drawn in. So here's my water. Here's my boat. Okay. Then here's the bottom of the ocean. And the shipwreck is directly below it. So there's my wrecked boat in two pieces, I guess. And then I have a scuba diver down here somewhere. We'll put him here. So he's going to look dead, but he's not dead. He's swimming. Okay, so there's my scuba diver because he looks up to see his boat, he looks down to see the shipwreck, so he's somewhere in there, right? So then it says, let's see, the scuba diver spots a shipwreck at an angle of depression of 26 degrees. So before he can look at the shipwreck, he's got to look straight ahead, then he looks down. And that is your 26 degrees. The angle of elevation from the scuba diver up to his boat is 53 degrees. So he looks straight ahead, then he looks up. This is 53 degrees. The shipwreck is directly below his boat. The horizontal distance between the scuba diver and the shipwreck, so this right here, this horizontal distance, this is 120 feet. Find the vertical distance between the shipwreck and the boat. So I'm looking for this. Well, this part right here that is 120 is the same as this right here, right? So this right here is 120 feet. I got two little right triangles. If I want that total distance, then I can find x and I can find y. And the total distance is just going to be what? X plus y. Easy enough? Do you see I drew that picture in pieces? Like, I wouldn't just slop a triangle up there and try and figure out what the heck is going on, because it's not going to work out too well for you most of the time. We good? All right, what questions? So again, I could have put just a point here and put a B for boat and an S for shipwreck and a, D for diver, like whatever. It doesn't have to be picture, but you need to know where the stuff is at least. Okay? Any questions? We're good?